This is section 7.4, equations in quadratic form. So you're going to be doing some factoring, you're going to be using some quadratic formula. It'll be jolly good fun. So how do we recognize and solve equations in quadratic form? Well, in general, an equation is in quadratic form if it can be written as a times f of x squared plus b times f of x plus c equals 0, where a is not equal to 0 and f of x is some function of x. If desired, you may substitute f of x by some variable and substitute back once you've solved the new equation. So what we're going to do today is you're going to see equations in quadratic form. So it's going to be very similar to what we've looked at the past few days. Ax squared plus bx plus c is the general form, but you're going to have some complicated function instead of an x. What you can do is you can plug in a variable, for example z, into that function and substitute it in so it's a more nicer equation to look at. I know that was really brilliantly put. So let's take a look at example 1. X to the fourth minus 9x squared plus 8. So what you could do, and you don't have to do this because if you can kind of see what the equation looks like, you don't necessarily have to substitute. So let's let z equals x squared. So if you substitute, x to the fourth is x squared squared. So that's z squared. X squared is just z, so we plug in z for x squared. And so your new equation is z squared minus 9z plus 8. So you will go ahead and factor this. You get z minus 8 times z minus 1 equals 0. So z is either 1 or 8. Now what you have to do is take your values of z and plug it back in to the substitution. So in substituting back, you get x squared equals 8 or x squared equals 1. Now you solve each of these equations separately. So if x squared is 8, x is plus or minus 2 radical 2, or if x squared is 1, then x is equal to plus or minus 1. So your solution set is plus or minus 2 root 2 and plus or minus 1. So again, what you're basically doing is with the equation in quadratic form, you're going to substitute a variable for x squared. And generally what you're going to do is you're going to take this z and look at this b term there. And that's what is going to tell you you should substitute for. Since here the middle term is x squared, you're going to call z x squared. And we'll see different examples of that coming up. Example 2, x minus 5 radical x plus 6 equals 0. So again, what you want to do is substitute. And I would again look at the middle term. Once you have the equation in order, and obviously in some of the examples you're going to have to rearrange the equation. So you see that the middle term, the b term, would be radical x. So that tells you what you want to substitute for. So let's let z equals radical x. So now you substitute. X is merely radical x squared. So that's z squared minus 5z plus 6 equals 0. And again, all you have to do is solve for z. Now by factoring this, you get z minus 2 times z minus 3. So z is either 2 or 3. Now again, you have to substitute back. So now you get the square root of x equals either 2 or it equals 3. And then you solve each equation. You can square both sides. So x is either 4 or x is 9. And that's how you do these equations. So again, put them in the right order. This one is given to you in the correct order. Substitute z for what looks like is going to be the quote-unquote linear term of the middle term, and then plug it in, and you should get a quadratic equation similar to this. Example 3, 2x plus 2 square root of 2x minus 15. Go ahead and try this one yourself. Remember to substitute for what looks like is f of x, and often it will be right in the middle. Alright, so let's let z equal radical 2x. So what you've noticed is that 2x is radical 2x squared, so that becomes z squared. Radical 2x becomes z. And so your equation is z squared plus 2z minus 15. Now, you should be able to factor this without much difficulty. Z plus 5 times z minus 3 equals 0. So z equals negative 5 or it equals 3. Now you must plug it back in the equation. So you have the square root of 2x equals negative 5 or the square root of 2x equals 3. So The square root of 2x equals negative 5. No principal square root can ever be negative, so there's not going to be a solution here. So you can't just square both sides and solve it, because you again have to remember that when you square root a number, it's never going to be negative. Or 2x equals 3. So, in this case, 2x would equal 9, so x equals 9 halves. So the only answer to number 3 is 9 halves. So you can solve these on your own. Just make sure, again, if you have a function of x with a square root, that you cannot accept any negative numbers as part of a solution. Here you can solve it just by squaring both sides and then dividing by 2. Example 4, 6 over u minus 17 over radical u equals negative 5. The way I like to do these is to first rearrange them in order of the highest exponent to the lesser exponent, and then set everything equal to 0. So I'm going to add 5 to both sides and do this. Now you'll notice that the u is basically x to the first power, and the square root of u is less than x to the first power. So let's rewrite it like this. 6 times 1 over u minus 17 times 1 over radical u plus 5 equals 0. Now it's pretty clear to see what you need to substitute for, because this is 1 over radical u squared. And now you can substitute z equals 1 over radical u. Now you don't have to rearrange this every time. I'm only doing this to show you where the substitution is coming from. In fact, if you're doing this on a test or something, or your homework, you can just jump straight from here to here if you can see what you need to substitute for. But once you substitute, you get 6z squared minus 17z plus 5 equals 0. Now you just factor it. If you use the box, which I'm not going to do here, you will see that it's 3z minus 1 times 2z minus 5 equals 0. So your z values are 1/3 and 5 halves. Now you have to go back to the original substitution, plug in these values of z, and solve for u. So we have 1 over radical u equals 1/3, or 1 over radical u equals 2/5. So by cross multiplying, you can see that radical u is either equal to 3 or is equal to 2/5. So u is 9. By squaring both sides, you get u is 9. And here, squaring both sides gets you 4/25. And that is your answer to example 4. So, again, if you can see the relationship as to what f of x is, you can go ahead and substitute without doing the extra step. If you're having a more difficult time seeing it, rewrite the equation and see if you can find out what the function of x you need to substitute for is. Number 5, 4 plus 1a squared equals 3 radical 2 over a. I would try this one yourself before you copy down what I write and see if you can solve it. So again, I like to rearrange it in sequence. So we now have 1 over a squared minus 3 root 2 over a plus 4. Again, I'm going to show you every single step. You don't necessarily have to do this when you solve the problem yourself. You will see that this term is 1 over a squared. The middle term is just 3 radical 2 times 1 over a plus 4 equals 0. And this gives you a good idea what you need to substitute for. So z is going to equal 1 over a. Now you just plug in z for 1 over a to get z squared minus 3 root 2z plus 4 equals 0. Well, can't really factor this because you don't have integer coefficients, so we're going to use the quadratic formula. So b is negative 3 root 2, a is 1, c is 4, so plug that in. 3 root 2 plus or minus the square root of negative 3 root 2 squared minus 4 times 1 times 4 all over 2 times 1. If you solve that and simplify that, you get 3 root 2 plus or minus the square root of 18 minus 16 over 2, which means that you're looking at 3 root 2 plus or minus root 2 over 2. So you have two different z values. Z can either equal 4 root 2 over 2, which is 2 root 2, or if you use 3 root 2 minus root 2, you get 2 root 2 over 2, which is root 2. So these are your two answers for z. Of course, you're not done yet because you have to substitute back into 1 over a. So 1 over a can equal 2 root 2 or radical 2. So a is equal to 1 over 2 root 2 or 1 over root 2. In both of those, you have to multiply the top and bottom by radical 2, which I'm not going to show you every little step. But you get a is radical 2 over 4 here, or radical 2 over 2. and those are your solutions for A. So some of these require a little bit of work. They take several steps. I don't think these are that difficult, but you just have to be very careful as to what you substitute for and when you substitute back to not make any algebraic errors. We finally have example 6. Quantity 2b plus 1 over b squared equals 2b plus 1 over b plus 6. So rearrange the equation. Rearrange the equation, and you get it to look something like this. In this case, it's pretty easy to substitute for the f of x, so go ahead and try that yourself, and then when you're done, solve for z and plug it back into the substitution and solve for b. Alright, so z is going to equal 2b plus 1 over b. Now you can substitute, so you get z squared minus z minus 6. It's pretty simple. It makes it look a lot prettier. So if you factor that, you get z minus 3 times z plus 2 equals 0. So our z value either equals 3 or negative 2. So now we can go back. So 2b plus 1 over b equals negative 2 or it equals 3. We'll do this one first. So just solve this algebraically. Multiply both sides by b. Add 2b to both sides. Subtract 1 and you get b equals negative 1/4. Now let's do the other one. We have 2b plus 1 over b equals 3, and again you're going to do this algebraically, and you get b equals 1. So your solution is negative 1/4 and 1. So when you do these equations, make sure you identify correctly what f of x is, solve it, and then substitute it back to solve for whatever variable you're looking for. So when you do these, you can either substitute, or you can even do problems like example 1 as a factor of x squared. You don't have to substitute if you can recognize what the quadratic relationship is between f of x and the factor. So that just saves you a step if you don't want to do it this way. But if you want to do it this way, it's probably better for many of you because that allows you to see the relationship between f of x and the coefficients and allows you to factor. Alright, that's it for section 7.4. No homework this time. That's going to be posted now. So, if you have any questions, please ask me. This ends the video. For reals.